Hey Mary, what do you think about like today? We do these stations where we're going to have like 16 stations, and then we'll group the kids together. Well, they'll walk around the classroom reviewing for the SOL.
That would be great. The only thing we need to do is for the for our special education students, we need to adapt the problems. Maybe have them do the odd ones or the even ones.
Okay.
And maybe have them in a group with some higher achieving students.
Oh, excellent. I'm thinking like maybe after they're done with this, if you can go over the answers with them,
Okay, I can do that part of the lesson.
and then to ensure that we know that they understand it, we can have a quick check, maybe 10 problems based on the questions around the stations.
That sounds great.
And then what they can do is we can grade it and so forth, and we can see who's still struggling and what we need to cover for tomorrow or a couple days down the road.
That sounds great. That would work perfectly.
So half the stations are going to emphasize the no calculator part,
Okay.
which we've been covering for the past couple weeks. But some of the stations I kind of worry about, like the inequalities, because these are the ones that the kids are having trouble with.
Okay. With the no calculator, remember the ones who get a calculator accommodation still
Yeah.
should be able to use it on that.
Definitely. Good point. But I think the inequalities, especially when they have to rewrite it, or
Yes.
the negative coefficients, those ones we have to focus on. Maybe we'll hover around those stations, like you and I, because I think there's 2 or 3 of those stations to make sure they're understanding it, and we can help them out when they're there.
Okay, that sounds great. Yeah, to make sure they're getting it.
And the other topic was they seem to be getting the theoretical and experimental probability confused. And I know one of our students, he's allowed to use a dictionary, so maybe we'll have him have a dictionary in case he can't remember.
Which
and
way the definition,
And
yeah.
he can sit there and just look it up and so forth.
Yeah, have it at the station would be great. That helps, because that covers his ESOL along with his SPED accommodations.
Fantastic. And the other one that I'm a little worried about is they're still having a little trouble with the translations.
Oh, yes.
And definitely before they start, I would like to do a little mini lesson before on this before we get started in stations, especially with the less than.
The less than, yeah, I see
Make
that.
sure it's an equation.
That's another one we can rotate through, keep it close to one of the other ones so we can be at both stations to help.
Excellent. Solving and graphing inequalities. First thing, open or closed circle. Open. It doesn't have a line underneath it. In which direction does it point? Right. So we know we don't have to turn the sign around. If we can do these 2 things, gentlemen, we can easily get rid of 1 or 2 wrong answers. What's the opposite of plus 5 here? Minus 5 on both sides. We have n is greater than negative 3. So we know it's an open circle above the negative 3 pointing to the right. Now when we say rewrite the solution a different way, if I flip-flop the negative 3 and the n, what's the alligator going to eat in this case? N. So it's negative 3 is less than n, is the same thing as n is greater than negative 3. If I take a look at this example problem, now another part I want to review is the theoretical and experimental probabilities. What's the difference? Wait, Blake's starting us off. What's theoretical? What could happen or what should happen, this is what should happen, are the results. It's what did happen. So if I take a look, this is our theoretical probability, this little spinner here. What's the theoretical probability of landing on a smile here? 1/4. Now the experimental, the results shows what did happen. Now it says, Kim spun her spinner 20 times and recorded the results in this nice little table. What is the experimental probability of getting a smile?
3 out of 20.
3 out of 20. Notice, these are not going to match at all times, guys. They're different. Results, what should happen? What's the theoretical probability of getting a rainbow here? 1/4. 1 out of 4 sections. A box has 4 blue, 2 black, and 1 red pen. What's the probability of getting a red pen followed by a blue pen? Now, what's the probability of getting a red pen?
1 out of 6.
1 out of 6. What's the probability of a blue pen?
3 out of 6.
3 out of 6 produces a 1/2. Good. We multiply these together, we get
1 over 12.
1 over 12. Now, without replacement, what happens without replacement to the denominator? Well, no, what happens? Without replacement.
It doesn't go back down.
And what happens to the denominator, Andrew?
Minus 12.
And minus 1. So the denominator changes. Now, if we take a look here, gentlemen, I'm going to draw a little picture, and you can always draw your little picture here if you're not sure. We have 3 blue. I'm right here are my 3 blue. I have how many black ones? 2 black? 2 black. And I have 1 red. Now, what's the probability of getting a blue pen?
3
Wait, blue pen is going to be 3 out of 6, which reduces to 1/2. You take the blue one out, you don't put it back in. How many pens do we have left? 5. And now what's the problem with the next one being black? Black. 2 over 5. We multiply, we end up with 1/5. Now, here's your assignment, gentlemen. You have 16 stations. They are labeled around the classroom. You can see the numbers are green. 5 is right here. A lot of people can't find 5. You're going to partner up with no more than 1 or 2 people. Now, some students, we're going to make sure we're going to group them together so that they can basically benefit from this little exercise. You will have 2 minutes and 30 seconds for each station. At the end, Ms. Ball is going to go over all the answers, and you will be taking a quick check. Gentlemen, you have 15 seconds to find a partner or 2 and get to an unoccupied station.
Done faster. 42. 3 more than twice is 11. So what would 3 more than? Where does that go? The beginning or the end of the problem? More than.
Times 1 out of 10 usually 6 times 6 10 times
Not 10 times 10, 10 times
10 times 9.
Odd number. That's an even number. 16, 25.
N is less than 18.
Where does the 5 less go?
It goes at the end.
Okay.
So 4 and then associates 5.
Good job, guys. What about the next one?
The period goes to last.
Okay.
And so 11 is
No. What's this?
equals O.
And what's probably this one would be?
German.
Which is 1/3 again. And that's the median
So
one.
it will be calculated at the end. And
So we have 1/3, 1/3, 1/3. What is the product? 1/3, 1/3, 1/3.
Please raise your hand and we'll go over it. So number 1 is 15. Number 2 is 3. Number 3 is 19. Number 4 is 10. Number 5 is 14. Any questions? Number 5. Into the 6. It's an even or odd number? Even. Okay? So 4 times 4 gives you 16 to make it work. Alright, number 6. N is greater than 5. N is greater than or equal to 27 for 7. Number 8, N is less than -6. And number 9 is N is greater than -1. Any questions on any of those? Yes, sir. Number 9. You have to rewrite. It's either where you have to rewrite it, change it. Okay. We are going to take our quiz now. The first 8 problems are without a calculator. All right, so you do not use a calculator on the first 8.
Gentlemen, once you're done, place them on the overhead, and then you can get started on the other assignment.